In this section, we are going to discuss the extrema of the function under certain conditions. These conditions we say constraints or restrictions. So that's in the same plane. And this method we call Lagrange multiplier. This is a very special case. We can have here 2 dimensions, 3 dimensions, 4 dimensions, any dimensions. We can have one condition, we can have more than one condition. There is a little modification in our method when we are going to do it, and we can accommodate this one. Before we are using only the extrema of the function of two variables, and they will discuss. But now here we are free, and also in addition to that, now we can also accommodate the restrictions on the function to find the maxima and minima. Here is that this method is Lagrange multiplier. For example, I take two-dimensional case. I have xy plane and I have a curve in xy plane. I want to find the distance to be maximum. So our distance to be minimum, depend upon the nature of the questions. So I have the function fxy. That's my distance d, and I have the condition gxy, that is the point is on the curve. This point is pxy, and this is on the curve, and we want to find the distance, minimum distance from the point from the origin. So this is my condition. So here we are finding the function fxy, and then we have the constraint, and this gxy equal to 0. This constraint, we say constraint, or we say it as condition, I say restrictions. Also we say shrut or shart in our language. So here, as I told you, it can be function of 3 variables fx, y, z, and the condition will be also function of 3 variables or 4 variables. The only one condition can be more than one condition. We have this method for that one. So here again we have the application of the gradient, and also we introduce the new parameter we call Lagrange parameter. So we say the gradient of the function fxy is equal to lambda times the gradient of the function gxy. Gxy is the condition. If there is an equation, here this is the function and this is an equation, so we can have the difference between these two. So here with this one, now we require to find this lambda. Lambda is Lagrange multiplier, the scalar. So we need to find the value of x and y and the value of lambda. So we need 3 equations for that one. We can write here this gradient as f of x, f of y is equal to lambda times the g of x, g of y, the gradient of that one, and multiply by lambda, we get here lambda g of x and lambda g of y. So these two are equal, so we can say here the equation f of x is equal to lambda times g of x, and I am having here f of y is equal to lambda times g of y. So this is my equation 1, this is my equation 2. So these must satisfy any value we are having here x and y. This must satisfy our condition that this must be on the surface gxy. So it means we are having also here third equation that gxy must be equal to 0. These are 3 equations. So our unknowns are lambda, x and y. So we will find the different solution of this one. We can have different values of lambda and have the value of x and y. For example, we have the value of lambda 1, and then we have x1, y1. We have the lambda 2, we have x2, y2, and so on. We drop the values of lambda and we find the value of the function at the point x1, y1. Here I can take one more, this lambda 3 into x2, 3, y3. So here I can take here this x1, y1. Then the value of the function at the point x2, y2. A value of the function at the point x3, y3, and so on. It can be a 1 lambda, and we can have different values. So here the largest value, this one, is maximum, and the smallest value, this one, is minimum. I will show you with the help of example more clearly that how we are going to apply this one, how we can find the solution. So I give an example for this purpose. I'm going to explain this method with the help of example. Example 1 is use Lagrange multiplier to find the maximum value of the function fxy subject to the constraint x plus y is equal to 16. So solution of this one, we having the function, our function defined is fxy is equal to xy. This is my function, and my condition which is here given to me, as I explained you before, the condition is in form of the equation because both are given in the form of the x and y, so sometimes it becomes difficult to recognize. So I say this is my x plus y equal to 16. I will say x plus y minus 16 is equal to 0, and say this is my condition gxy. So I have the function and I have the condition, and we want to find the maximum value of the function. So the step is use Lagrange multiplier given to us, solve this one. So that's my gradient of f is equal to lambda time gradient of g. As I told you, lambda is my Lagrange multiplier and I want to find the value of this one also. So gradient of f I find here, gradient of f is equal to f of x, f of y. This is my f of x. My f of x is y constant, is my y. My x is constant, is my x. And gradient of g is equal to g of x and g of y. And if we differentiate with respect to x, we get here 1. Differentiate with y, we get here 1. So my Lagrange multiplier, I get here, this is equal to y x is equal to lambda times 1, 1. And that's here, we can say here my yx is my gradient of f is equal to lambda and lambda. So I get here equations y is equal to lambda and my x is equal to lambda. There are two equations. Need third equation. And third equation I say that's the gxy equal to 0, the condition. And that condition was x plus y is equal to, we're having here x plus y is equal to 16. This is my third equation. I want to solve these three equations to get the value of x and y and lambda. Now here you can see from these two equations, x equal to lambda, y equal to lambda is equal to x equal to y. From the equations, this is on the third equation, this is my equation 1, this is my equation 2, and this is my equation 3. I substitute third equation, I get here x plus x is equal to 16. I get here 2x is equal to 16. I get the value of x is equal to 8. I put the value of x in my equation 4. I get the value of y. The value of y is equal to also 8. So this is my value of x and y. So I have the product function fxy is equal to xy. So the maximum value of the function under the conditions given to us is f of 8 into 8. That's f of 8. We're having here f of x is equal to 8, y is equal to 8. This is the 8 multiplied by 8. 8 multiplied by 8 is equal to 64. So we find here the maximum value of the function by using Lagrange multiplier.